Welcome to Chemistry by JJ. In the sequence of name reaction videos, I am now discussing about Mitsunobu reaction. So let's get started. It is an organic reaction that transforms primary or secondary alcohol into thioethers, phenyl ethers, esters, and various other compounds using an aza-dicarboxylate such as diethyl aza-dicarboxylate or diisopropyl aza-dicarboxylate and triphenyl phosphine. So what happens in this reaction? Alcohol, primary or secondary alcohol, converted into different products. In this reaction, carboxylic acid, any carboxylic acid taking as nucleophile which attack on activated alcohol, and activation of alcohol is done by the help of these two reagents, either diethyl aza-dicarboxylate or diisopropyl aza-dicarboxylate and triphenyl phosphine. So I am discussing here the structure of diethyl aza-dicarboxylate or diisopropyl aza-dicarboxylate and triphenyl phosphine. This is the structure of diethyl aza-dicarboxylate. In this structure, you can see two ethyl groups are there. This group is known as aza groups and these are carboxylate groups. So the name of this compound is diethyl aza-dicarboxylate. In the diisopropyl aza-dicarboxylate, these ethyl groups are substituted by isopropyl groups. This is the isopropyl group. So the structure of diisopropyl aza-dicarboxylate is, this is the structure of diisopropyl aza-dicarboxylate. You can see here diisopropyl group is present with aza-dicarboxylate group. Now what is the structure of triphenyl phosphine? This is the structure of triphenyl phosphine. For understanding, we have to know about the mechanism of Mitsunobu reaction. Mechanism contains 4 steps. First step is the formation of Zwitter ionic intermediate or adduct formation. In this step, triphenyl phosphine react with diethyl aza-dicarboxylate and form Zwitter ionic intermediate. What is Zwitter ionic intermediate? Zwitter ions are those species which contains positive and negative both the charges, and it is electrically neutral ions. So this is our diethyl aza-dicarboxylate. React with triphenyl phosphine. This triphenyl phosphine contains lone pair, and this lone pair attack on this nitrogen, and this double bond breaks and the electron shifted to this nitrogen, and Zwitter ionic intermediate are formed. So the structure of Zwitter ionic intermediate like this. Zwitter ionic intermediate. This is the structure of Zwitter ionic intermediate. Now forwarding to second step. Second step is abstraction of proton from nucleophile. In this reaction, we are taking a nucleophile, generally any acid. So you all knows acid contains acidic hydrogen, which is easily abstractable by any electron rich species. So Zwitter ion abstract this Zwitter ionic intermediate abstract this proton and form an anionic nucleophile. In the fourth step, this anionic nucleophile attack on activated alcohol. So what happened in the second step? This is our Zwitter ionic intermediate. This nitrogen abstract the acidic proton of nucleophile and it will form another intermediate. Another intermediate looks like this. In this intermediate, only positive charge is there. Now forwarding to third step. Third step is alcohol activation. Okay, so alcohol activation is done by the intermediate of second step. Intermediate formed in the second step. So what is the intermediate formed in second step? This intermediate formed in the second step. It will react with alcohol. Now oxygen contains two lone pair. So this lone pair attracted by this positive charge and this bond is shifted to this nitrogen and this nitrogen now becoming electron rich species. Nitrogen abstract this hydrogen from alcohol and oxygen attached to this PPH3 group. Now another intermediate will be formed which is activated alcohol and this reagent form and product. So this is our activated alcohol and this is our reagent. Now forwarding to fourth step. In fourth step, nucleophile anionic nucleophile attack to activated alcohol. This is our activated alcohol and this is our anionic nucleophile. This anionic nucleophile attack to this carbon present in the alcohol. This nucleophile attack to this carbon and form inverse product. Why it is forming inverse product? Because on the front side this bulky PPH3 group are present, so only the back side is clear for the attack. So nucleophile attack from the back side on the activated alcohol and it will form inverse product. So these four steps are included in single reaction. This is our alcohol and this is our acid, means our nucleophile. When it react, it will form inverse product reagents. Reagents are diethyl as a dicarboxylate, and triphenyl phosphine. So this is the general reaction of Mitsunobu reaction. I hope you all understand this reaction, and this reaction is SN2 type reaction, because you all knows in SN2 reaction inverse products are formed. So here you can see inverse products are formed because on the front side bulky group are present, so the nucleophile attack on the back side. Thank you for watching this video. Like and subscribe this channel for more videos.